Now, next numerical we'll see a smooth pipe of diameter 400 mm and length 800 meter carries the water at the rate of 0.04 meter cube per second. Determine the head loss due to friction, wall shear stress, centerline velocity and thickness of the laminar sublayer. Take the kinematic of the water as 0.018 stoke. Okay, we'll see that problem. First, we'll write down the given data. Okay, what is given? Anybody? Now see the diameter, length, then other parameter they are given, and this problem was asked for 10 marks in 2017. Okay, so it is very simple. We'll see one by one. Okay, given data. Okay, what is given? D is given 0.4 meter, then length 800 meter. Okay, Q 0.04 meter cube per second. Then kinematic viscosity they are given in stoke, so directly I will write here meter square per second. Okay, so first we'll calculate average velocity, Q divided by Q, you know that, D, pi by 4 into D square. Okay, so it will come 0.318 meter per second. Second, the Reynolds number, RE value, UD divided by kinematic viscosity. So this U, you substitute, so you will get 70123.67. Ultimately, a Reynolds number is more than 4000. It means what? This is what? Turbulent flow. Now see, here we require the coefficient of friction. How to calculate coefficient of friction? It is very simple. F equal to 0.0791 RE raised to the power 1 by 4. So you will get 0.0048. Okay, so from that formula we are able to find out, yes, coefficient of friction. Second, the head loss by Darcy's Weisbach equation. What is Darcy's Weisbach equation? So HF equal to 4FL V square upon 2GD. If you know this coefficient of friction, here we know that, here V. So this velocity you take, then HF equal to 0.1979 meter. Then next, wall shear stress. How to calculate? I will tell you. Up to this you understand? So wall shear stress. So what is formula? F rho U square divided by 2. Okay. So substitute that value. Density. Then coefficient of friction 0.0048. Newton per meter square. This is what W. Okay. Now next, the centerline velocity. Now see here, the centerline velocity, it means what? This is our pipe. Now velocity distribution diagram. Here u equal to 0, here u equal to 0, but here u max. Here the d, it means what? This is capital R, isn't it? Okay. Now you understand? Now I will tell you centerline velocity for the smooth pipe. So u divided by u star equal to 5.75. This is standard formula. Write down y divided by nu plus 5.55. Okay. So now see, if you know the shear stress, so shear velocity will calculate how? So under root tau 0 divided by density, and it will come 0.01557 meter per second. Okay. So now see, all parameters we know that the velocity will be maximum when the y d by 2 0.2 meter at y equal to 0.2 meter, so u equal to u max. Okay, so this is the condition, and we will substitute in that condition in this equation. So you will get u max equal to 0.3763 meter per second. Okay. Now next is the thickness of laminar sublayer. Thickness of laminar sublayer. Now see here, this is one plate, this is profile, okay. I will tell you here what is the thickness. So this distance represent your thickness. Okay. So one standard formula is there, del dash equal to 11.6 into kinematic viscosity into shear velocity. So all value you know that. Shear velocity. So ultimately your del, that is 1.34 mm. It means this distance, thickness of laminar sublayer. Now you understand? Okay. Next, we'll solve another problem. In a pipe of diameter 100 mm, the centerline velocity and the velocity at a point 35 mm from the center as measured by the pitot tube are 2.7 meter per second and 2.4 meter per second respectively. Assuming the flow in the pipe to be turbulent, find first the discharge through the pipe second coefficient of friction, third the height of roughness projection. Okay. First we'll write down given data. What is given? D 100 mm, it means 0.1 meter. Then R it is not given, but here I am calculating. In meter 0.05. Okay. Now the centerline velocity Umax, that is given 3.7 meter per second. Then the velocity at y equal to, so here 0.05 minus this small r, they are given the 35 mm. Okay, so it means 0.03, so it will come 0.015. Okay, at velocity 2.4. At this velocity, this is your y. So how to calculate discharge, then coefficient of friction and K, thickness. We'll see. First, that standard formula. Okay, this is the standard formula. Substitute that all value and find out the shear velocity. Okay, so now see here 2.7 they are given minus 2.4. Shear velocity we required 5.75 log 10. Yes, R value. What is the R value? 0.05. 0.05 divided by 0.015. So ultimately, you use shear velocity, you will get 0.099. You can say that 0.1 meter per second. Round figure we are considering. Okay. Now, if we know the shear velocity, so we are able to find out shear stress. How? With the help of this formula. Okay. Substitute all value, find out this, and it will come 10 unit Newton per meter square. Okay. Now, if you know that, substitute that all value, you will get the discharge. How to calculate discharge? First, what we required? Coefficient of friction. How to calculate coefficient of friction? With the help of Reynolds number. First, you find out Reynolds number. How to find out Reynolds number? Yes, UD upon kinematic viscosity. So kinematic viscosity, first you find out U. So take U, kinematic viscosity, you assume it if it is not given. Okay, with the help of that formula you are able to find out coefficient of friction. Then substitute that all value to find out one relation. Okay, so you will get velocity and then find out the discharge. Okay, next nil. For the turbulent flow in a pipe of diameter 300 mm, find the discharge when the center line velocity is only 2 meter per second, and the velocity at a point 100 mm from the center as measured by the pitot tube is 1.6 meter. Now see, this problem is for 10 marks and it was asked in 2012 and 2014. Okay, only 2 steps it is required to find out the discharge. Okay, how to find out I will tell you. First we'll write down the given data. It is very simple. First write down given data. Yes, what is that diameter they are given? 0.3 meter. Then what else? Diameter, yes, first we will find out R. R they are given, yes, they are not given, but I will calculate here. 0.075 meter. Okay. Not this. First, whatever it is given, we will discuss Umax. That is 2 meter per second. Okay. Now, the velocity at R, small r, equal to they are given 100 mm from the center. Here, from here to here, total how much? 300. Okay, from here 100, center of from the center line. So for this U equal to 1.6 they are given. Okay, then here I will calculate Y. Y means what? Capital R minus small r. So here 0.15, okay, minus 0.1 equal to 0.05. Now one standard formula is there. You write down U max minus U shear velocity equal to 5.75 log 10 R by Y. So here R means what? 0.15 by Y. Okay. So if you will substitute that all value, this U max how much? 2, and this is what? 1.6. So ultimately U star you will get 0.1458 meter per second. Okay, if you substitute all value over there, so you will get that. Then next, the relation between velocity at any point. The relation between velocity at any point and average velocity. At y equal to r, u equal to u. Okay, so here one standard formula is there. U max, U average, U star. We require this velocity, average velocity. So how to find out average velocity? With the help of this formula. Okay. Now see here, if I will substitute y equal to r, this condition, so this term will get cancelled. So what is the maximum velocity? 2 average, and this one is 0.1458 equal to 3.75. Okay. So ultimately average velocity will come 1.453 meter per second. Okay, so this is your average velocity. And last, what they want? Find out discharge. This is most important for previous problem also. Okay, same condition you apply here, then you will get discharge. How to find out? Q equal to area into velocity. What was the area? 5/4 into d square. What is d? 0.3 square. Velocity 1.453 average velocity. So ultimately you will get 0.1027 meter cube per second. This is your discharge. Okay, this is the way to solve such type of numerical. Okay, thank you.